Hello and welcome to another TechNet Live webinar series based around modernizing your data center with hybrid cloud and Windows Server 2016. My name is Jeff Alexander. I'm a senior technical evangelist here at Microsoft, and you can get in touch with me at http://about.me/Jeffa36. So this is the second in our series of TechNet Live webinars based around this topic. And the first one was kind of an introductory session talking about what we're doing around cloud. We were going to do virtualization next, but that happened to fall on the Easter Friday, so we're rescheduling that for later on. So today we are talking about storage and some of the storage enhancements that are in Windows Server 2016 and what we believe is happening in the industry around storage. So this section is all about software-defined storage in Windows Server 2016, as I said. And what we're actually looking to do here is to, first of all, this session is going to be broken down into two areas. First of all, we'll give you our strategy around storage, in particular around our on-premises software-defined storage strategy. And then move on into what are we actually doing around Windows Server 2016 when it comes to the storage enhancements around the platform. So let's get started and have a look at what we're doing. So obviously there are a number of trends that are influencing what is going on right now in around storage. And there's a number of influences. And if I had to call out a couple of these, there would be some that would really stand out more than others. The first of all is around data explosion. We all know that there's a data explosion going on right now. Data is probably one of the most important things that we're hearing from customers. There's a number of things that are driving that. There's modern applications, there's unstructured data analytics, and this is putting a lot of pressure on organizations to be able to scale out their solutions with simplicity. There's also some evolving technologies that are going on right now, and if I had to talk about one of the technologies that is the most influential right now, it's about Flash. Flash is really transforming the storage industry, particularly in the data center around using Flash, using NVMe type Flash. We're also looking at, networking is moving to the next level. It is really in a position right now to be able to deliver extreme performance. And what we're doing in Windows Server 2016 is we're taking our infrastructure that we're using in the cloud, what we call cloud-inspired infrastructure and design, and bringing that back into our on-premises solution. And this is all the more true in regards to hardware. So we're really talking to customers around using industry standard hardware to take that hardware and be able to build very reliable software defined storage scenarios. So these are some of the trends that we actually see going on right now in the industry that are driving a lot of what's going on in regards to that. And we're designing Server 2016 in regards to that. So let's have a look and move on into what we're doing. So Microsoft as a company is, first of all, we are a cloud company. This session is really going to talk about our on-premises storage and what's new in Windows Server 2016. But I wanted to actually quickly pause for a second and really talk to you about what is our enterprise strategy. We start obviously with our bread and butter, which is our on-premises storage, and we've been doing that for many, many years. Storage Spaces was introduced in Windows Server 2012 a few years ago, which is the beginning of our journey in regards to software-defined storage. And this allowed you to manage traditional SAN, NAS connectivity to support virtualized environments and private cloud environments. We've started to hear a lot more about hybrid cloud storage, and this is really the connection point that Microsoft has into the public cloud. Now, Azure Storage is available in Microsoft Azure for scalable, reliable cloud storage for all the different types of data that you have in the storage. But how do you connect these two together? And that's where we're doing a lot of work in that space, particularly around using our StoreSimple products and other third-party solutions to provide a solution to give you on-premises storage integrated with Azure Storage. So allowing you to take hot and cold data and move that up and down the stack as needed. And then, of course, Azure Site Recovery and Backup, providing the availability that you're going to need on demand. So we're really the only vendor that gives you the ability to have both of these particular scenarios. What I'm going to be talking about today in this webinar, however, is what we're actually doing in Windows Server 2016 to address the on-premises storage piece. So let's have a look at that. But first of all, I want to explain to you some of the different choices that we're talking about. Now, a few years ago, obviously, Microsoft came out in 2014. We came out with, sorry, 2012. We came out with storage spaces. And I, like a lot of other technical folks at Microsoft, were really excited about the fact that we were beginning our software-defined storage area. This had an interesting effect in the sense that a lot of customers that I talked to said, well, what are you saying? Are we get rid of our SANs in our environment, totally get rid of those altogether? And that's not what we certainly want to say now. What we meant to be saying before is that Microsoft, first of all, is a cloud company, and we embrace your choice of storage for your cloud. Now, we can use, if you're using a traditional SAN or a NAS head type device, and really what we're about is to be able to reduce storage. So we offer a leading portfolio to build on-premises cloud. We embrace the choice that you actually want to do. Our goal, however, is to allow you to reduce your storage costs. So whether you're actually going to be starting, we're going to talk about a new feature in Windows Server 2016 called Storage Spaces Direct. So whether you're using that, whether you're using storage spaces today, whether you're using a SAN partner, whether that's Fiber Channel or iSCSI, through a number of our SAN partners, file-based storage, whether you've got NAS, you're back-ending this into a NAS head using the SMB3 protocol to allow people to connect to that, and then connecting up the cloud fabric into that, whether it's Azure Stack or object-based storage. So remember that Microsoft is a cloud company, but we do give you choice when it comes to on-premises storage. Now, having said that about what is a SAN really? And I just wanted to, before we moved into some of the new features, a lot of customers that I actually talked to are not aware of a lot of the stuff that we did in Windows Server 2016. In Windows Server 2012, which was about 4 years ago. So when we talk about this, a SAN, what is a SAN really? A SAN is essentially, you get a bunch of disks. Now these could be flash-based disks or spinning media, hard drives to provide raw storage capacity for your data, right? They get pulled into controllers, sliced into LUNs, and they can be put into some sort of RAID scenario, whether that be simple, mirrored, or parity. It's a pretty common thing. And then somewhere along the line, we have some controllers. This is really the brains of the SAN. Okay, so this is typically a device. It's a device that has an x86 CPU in it. It has some memory, had some enterprise features. And a lot of SANs give you the ability to have things like thin provisioning, deduplication. They'll do some sort of tiering to allow you to separate hot and cold data. So they'll have a number of different ways that they can actually do that. And then, of course, you have your connectivity adapter. So how do you actually connect? These are either going to be your iSCSI, fiber channel over Ethernet, NFS, or SMB. Now, this is traditionally what a SAN would look like, and a lot of customers have been using this for a number of years. Now, what does it look like when we bring Windows Server into the mix of this? And when we talk about software-defined storage, what does this actually look like? Now, if we move into this, of course, you're always going to start with your physical disks. In Windows Server 2012, we gave you multiple options for low cost and low complexity. This was, you could have a mix of spinning disks, SSDs. They would either exist in an external JBOD, which is short for just a bunch of disks, connected via some sort of SAS controller or within a file server chassis itself. But the difference is that Windows Server is now the controller. Okay, so Windows Server is now the brains of this environment, of your software-defined storage environment. What we do is that we're able to actually cluster Windows Server file servers or scale-out file servers to create disk pools, storage pools, that allows you to then slice them up into storage spaces. And in Server 2012 and 2012 R2, you could do thin provisions, you could do tiering in 2012 R2. We have full support for deduplication, and they can be simple, mirrored, or have that parity. And very similar to what you would see in your SAN environment, and it would be very similar in the way they do it, but all being done via software. Now, the connectivity adapters that we support for Windows file servers to have resilient, they need to have some sort of resilient connectivity to external sources. You can use regular 1 gigabit Ethernet, 10 gig E. We have support up to 56 gigabytes, 100 gig RDMA adapters. If you want to get really super fast performance, you can use up 56 and 100 gig RDMA adapters. And we support iSCSI, SMB3, and NFS connectivity. Now, that is something that's been around for quite a long time with Server 2012 and 2012 R2. This has been in market. It's been something that we've had in box available to you. And there's a lot of customers that we'll show you in a second that have been using this technology. But then we have this notion of what we call hyper-converged with Windows Server. Now, if we collapse all that, now in Server 2012, we relied on some sort of shared storage connected in some sort of way. Now what we're actually doing is we're taking a lot of the cloud design points that we used in Microsoft Azure, and we're introducing a new technology in Windows Server 2016 called Storage Spaces Direct. And this is essentially where you have a standard bunch of servers, and here you can see an example of a hyper-converged architecture with a bunch of disks that are just locally attached disks, and we commonly call those DAS, or direct attached storage. They can be lower cost flash storage with SATA SSDs, and you can also leverage better performance with the new, as I talked about, one of the flash technologies, NVMe SSDs, which are PCI flash devices that give you better performance and allow you to do that tiering. Now, we're going to have prescriptive hardware configurations, and I'll talk about that in a second. But essentially what this gives you is real flexibility. You get fault tolerance to disk enclosures. You can do stretch clusters, scale pools to a large number of drives. Fast VM creation with efficient snapshots. And the way that it actually is, we're going to be doing this is that we're going to really, so this is around when we talk about hyperconverged, is collapsing storage and compute. So that it's very easy for us to enable a cluster to support Storage Spaces Direct. And what we're going to be really doing with this is to use Ethernet or RDMA as the storage fabric, as the connectivity point between these servers. And this is really where we're kind of moving to this software-defined storage. So Storage Spaces Direct is a really key thing that we're looking at in Windows Server 2016 as the new thing that allow you to kind of move to these hyper-converged models. Now, of course, we want to make sure that we don't have too many partners. These are currently the development partners that are working with us right now, and we want to make sure that first we crawl, we walk, and then we run. So we're not coming out with a whole bunch of systems that support Storage Spaces Direct. We're working with a very small number of partners to make sure that we get it right, and we don't just using off-the-shelf hardware. So this is a list of vendors that are currently doing this, and we want to make sure that they get this right and they're supporting this particular technology. And if you look at this, hyperconverge is allowing us to scale from commodity to the cloud. Okay, so what we're trying to do here is to give you the ability to choose either model. And you see the converged model is what we had in Windows Server 2012, which is allowing us to use shared storage across a JBOD enclosure or whatever that may be. Hyperconverged is just basically servers that have storage in those, and it's ideal for like branch offices, remote offices, small, medium businesses. But for larger, having converged architecture allows you to scale independently. What we want to be able to do is give you that flexibility to scale regardless of the scenario that you actually use. So that gives us that capability, being able to. Okay, so let's have a look at what Storage Spaces Direct looks like, and just have a look at a quick demo. Scale from the cloud to the data center. Now, what I'm going to do now is I'm going to do a little bit of a demo to show you how we actually go about enabling Storage Spaces Direct, so you can see what it looks like. And then also showing you, so you can kind of quickly see what that's all about. And then we'll come back and we'll continue on. So let's just have a look at Storage Spaces Direct. and have a quicker look at how this works. Okay, so that was a quick look at Storage Spaces Direct, a very quick look at what Storage Spaces Direct looks like. The next thing we're going to look at is we'll talk more about the converged model and what we're actually seeing in regards to that. And if you look at the converged model, Microsoft believes in having your compute layer below cost commodity scale out. It's cost prohibitive to put expensive HBAs in each compute node. So we believe that low-cost Ethernet is going to be the real enabler at the storage fabric layer. So this is a traditional model that you actually see here. This is essentially what we'd call a converged software-defined storage, and it's really something we've been providing for quite some time in Server 2012 and up. You simply have your scale-out file server, you have your Elastic optimized, your storage optimized with storage spaces. This could be a NAS head. And then what we do in that is that we have our inexpensive Ethernet for storage fabric, and really relying on the SMB3 protocol to allow us to be able to do that. And we can scale out compute with low cost commodity servers in a Hyper-V cluster. And as I showed you, doing Storage Spaces Direct. It allows us to be able to do that. And, you could have a server as a NAS head, which is backed by storage spaces, and use low-cost JBOD type storage. And the goal here is to be able to have flexibility, scalability, and manageability across all layers here. Now, of course, when we look at our strategy, really is around choice for the converged infrastructure. We're really focusing on giving you the choice of choosing. Our strategy is for converged, disaggregated architecture running Hyper-V over SMB. It could be a third-party NAS device, scale-out file server with a SAN, scale-out file server with Storage Spaces Direct. You can do scale-out file server with Storage Spaces Direct. Heck, you can run a SQL Server database on a Storage Spaces Direct cluster if you wanted to. Scale-out file server with storage spaces. And that could be your JBOD type enclosure. And what we want to emphasize here to you is that we give you choice. NAS or software-defined storage. We give you the choice, and basically the idea is for file-based storage is that we're using Ethernet / InfiniBand with SMB 3.0. SMB is the enabler for the storage fabric. It allows you to, we're not telling you to throw out your existing SAN infrastructure. It allows you to leverage your existing investments, allowing you to repurpose the existing storage into our software-defined storage stack. And then, of course, you can manage the entire system with System Center Virtual Machine Manager. So that allows you to manage the entire environment. We'll have full support for that. Now, a lot of people ask us, what customers are actually using this, and you'll see that I'm scrolling by a whole bunch of different customers. We've got a couple of examples here of customers that are using storage spaces and some of the stuff we're getting. For example, here, ClearPoint, by using storage spaces, they're getting 450,000 IOPS and roughly a gigabyte per second in throughput. And in their case, it was more than 20 times their SAN. So those case studies are all available on our website. Have a look at those, because a lot of customers that I talk to haven't really seen a lot about what customers are doing in regards to this, in regards to storage and storage spaces. But have a look on our website so you can have a look and see what customers are doing. Now, what we're trying to do here is to say that, if you look at that, when it comes to what we used to do, Microsoft, we've been running do-it-yourself for 20 years, and we've had a Windows Server certified program or a logo program that's been going for a number of years. You can go to our HCL hardware compatibility list. You can go, I like this server, I like that NIC, I like that switch. And you can build your own infrastructure of all that different types of hardware, put it all together, and you'll have a proven platform that'll allow you to do that. That gives you the ability to do customization. But we're saying that, but at the same time, that actually takes quite a lot of skills inside an organization. You have to have the people that understand the hardware that they're choosing. It can be a daunting scenario. And what we're trying to do going forward is to give you a set of options that will help you not only customers, but service providers um, use our systems in a much easier way. And so we have the cloud platform standard system, which is a small package. It's built out of the box with a scale-out file server, CSV, RFS, storage spaces direct. It's validated storage on certified hardware. And you saw the list of people that we're working with in regards to storage spaces direct. It's a key building block for Azure Stack as well, which we talked a little bit about in the first webinar that we did for Azure Stack to allow you to really asymmetrically grow your storage. And then if you look at our higher end for hosting providers, which is our cloud platform system premium, that gives you your MAS scalability and resistance using certified components to create a validated solution. And it gives you the Azure integration, Azure Pack Portal, automated patching, and all that kind of stuff. Much bigger system, much more standardized. So we want to make sure that we're giving you that choice, whether you want to do the cookie cutter approach or you're going to move to a standardized system. So when we look at this, we want to make sure that from a partner stands point of view, that we have the ability to integrate. So for example, we have a cloud-powered empowered SAN, which integrates. So we have our Azure Site Recovery Management or hardware replication and site failover, so that you can use Azure as your site recovery. And then you can back up your storage. So rather than having a separate site where you're doing your backup of your storage, you can back up your traditional storage array to the cloud. And then when we look at from a management point of view, System Center Virtual Machine Manager will be able to allow you to give you that end-to-end management. It'll handle storage spaces direct. It'll allow you to go through and look at each scenario and set up storage spaces directly from within Virtual Machine Manager. Deep health and availability of your storage, and also integrating storage quals for controlling noisy neighbors inside that particular environment. So we're going to talk about storage replica in a second, but reducing disaster recovery with an in-box software replication at the block level. This is the first time that we've done it at the block level with storage replica. And having async and sync replication and lower with stretch cluster to be able to do this from site to site, and we'll talk about that in a second. So storage replica. Replica is really something that is the first time that Microsoft is now allowing us to do block level replication. This is not DFSR. This is not our other replication technologies. It's not Hyper-V replica. This is synchronous replication that is storage agnostic mirroring of data in physical sites with crash consistent volumes, ensuring zero data loss. And we do this at the volume level. This is really something new. This is a brand new thing in Windows Server 2016. It's not something else that we're kind of adding on to it. This is really for metro distance cluster to cluster disaster recovery. So if you've got site 1 and site 2, you can create a stretch cluster and allow you to actually replicate between those two sites. And we integrate into the to the graphical management for failover cluster manager. There's a new piece in there. And it's end-to-end for storage and clustering. And we don't care what type of file system you use. We don't care. We're not in that particular space with storage replica. Storage replica is at the volume level. So we don't care what type of file system you're using or any of that kind of stuff. We'll integrate with Hyper-V, with storage replica, storage spaces. We'll integrate into cluster, scale-out file server. Everything is going to be integrated there. So we can manage this graphical management through individual nodes or through failover cluster manager, and we'll also integrate into Azure Site Recovery. There'll be an update coming to that fairly soon that'll give you that ability. Okay, so now I'm going to let's have a look at what storage replica looks like. And in this demo, I'm going to show you a bit of a video of how this is actually configured and how we can set up storage replica in our environment. So let's have a look and see what storage replica looks like. We'll have a quick look at this so you can get an idea of how this is going to work in your environments. So let's have a quick look. Okay, so we're going to move into the final area, which is when we're talking about the cloud fabric. So the idea with our storage and a lot of what we're actually seeing in Windows Server 2016 is getting that consistency from Microsoft Azure. So Microsoft, our cloud storage offering is Azure Stack. And it's going to give you that consistency across blobs, tables, storage accounts, really giving you a IaaS storage through page blobs, page storage through block blobs. And it allows you to have a sort of a cookie cutter Azure consistent scenario around storage. Okay, so Microsoft Azure Stack is really designed for administrators, for tenants, for cloud hosters, to be able to provide this private cloud inside their organization. And we're basically taking the scenarios that we have in Azure and bringing that down. And to give you an example, clusters in Azure are kind of a minimum of 1,000 nodes. We don't know customers that have 1,000 nodes in Azure, but we believe that the scalability and the technology that we're bringing from Azure will work in some of the smaller type clusters that we have. So it's really giving you that resilient, scalable cloud storage services based on the storage of choice, whether you use software-defined storage, scale out, or leverage your existing standard investments. It doesn't really matter. The other thing we're doing, and we get a lot of feedback, is what we call from a storage perspective, is to be able to do rolling OS upgrades. Now, in Windows Server 2016, we have the ability to do a rolling upgrade from a server. So if you have a cluster that is running Windows Server 2012 R2, you can basically pause all the workloads that are currently running on one of the nodes in your cluster, evict it out of your cluster, and then re-provision that server with Windows Server 2016, either upgrade it or rebuild it from scratch, and then roll that back into the cluster and run in what we call a mixed mode scenario. That's very seamless for you and gives you zero downtime for upgrades for scale out file servers. So if you already have a cluster where you're using stored spaces, seamless OS rolling upgrades means that you won't have to have those systems down. And then essentially all you have to do is to upgrade that server to the new Server 2016 is to do that rolling OS upgrade and upgrade the cluster function level for that particular server. So a really cool thing we're adding in Server 2016 around rolling cluster upgrades. Now, of course, we've had clause there for a while. We had that in Server 2012 R2. And we're continuing the journey by default. And it allows us to give you simple automatic metrics for IOPS, both up and down the stack. So we have the ability to now, it's enabled by default. There's automatic metrics for VM and VHD. We can do it, we can set up policies, storage clause policies per VHD, per VM, per service or tenant. And we can now specify the minimum and maximum IOPS and have much more fair distribution with the policy. And then obviously from a management perspective, System Center and Ops Manager will be able to set up clause policies. Okay, so you can go into your fabric in System Center Virtual Machine Manager, create a new clause policy that'll get enabled. You could say create a silver versus a gold one, set your rate limiters that you want on that particular one, and then Ops Manager will be able to monitor what's going on in that regards. The other thing we've added to this, and we've made some changes to shared VHDX. There was some limitation with shared VHDX in the ability to be able to set up shared VHDX and do VHD resize without downtime. Now your guest clusters, you can now resize your shared VHDXs without downtime. So if you set up shared VHDX in a guest cluster, you'll be able to do that. Also in Hyper-V Replica, we didn't have the ability to support Hyper-V Replica if you were using shared VHDX. So if you have a guest cluster now that's using shared VHDX, we can protect that with Hyper-V Replica for disaster recovery. Host level backup, guest clusters now have the host level backup in addition. This was an ask that really came from hosting providers. And to be able to do guest host and guest level backups when using shared VHDX in those environments. Now, from a storage resiliency, what we're trying to do here is to really give more resiliency to transient activities, to really make VMs a lot more less sensitive in those scenarios. We're taking a lot of our queues from the cloud with commodity hardware. And what we do now from a resiliency point of view is that we preserve the tenant VM session state in the event of any storage disruption. So the VM, the stack is quickly notified of the failure, and then we do intelligent quick VM response to block all the file writes and file-based storage infrastructure issues. And then we move that VM into what we call a paused critical state and wait for the storage to actually catch up. So there may have been a glitch with the storage or something like that. And then what we can do is put that VM into a pause state, allow that particular storage to recover and catch back up again. And then it'll unpause itself once that's actually back incoming. We're also going to be, we have an inbuilt storage health service that we're going to be monitoring. And like in the past, there was a huge white paper to troubleshoot issues in regards to storage spaces. Am I having a problem with my storage subsystem? Is there any issues with that storage subsystem? And there's a huge white paper on how to do that. But we're building in a storage health service to allow us to do one monitoring point to debug the storage system, to get reports, which are integrated reports, fast and in the box. And if I want to actually do a disk replacement, fairly easy for me to do that, all supported through PowerShell and also Virtual Machine Manager. So really good to have that capability in and have that storage health system in there across the board. Now, one of the other things that we're adding into Server 2016 from a storage perspective is the ability to now use RFS. And if I asked any of you if this was a live audience and you're in the room with me, and I asked, put your hand up, how many of you used RFS in the past? Probably nobody would raise their hand because it was kind of I guess it was a V1 release with Server 2012 R2, and RFS wasn't really something that you could use. But now, we are saying, and now with RFS, if you have data stores, if you have storage where you're putting virtual machines, this is the file system that you're going to want to use to store your VMs. Why? Because we now have optimized RFS for storage spaces direct. So there's real-time tiering support, multi-resiliency in storage spaces direct, and it allows you to do a mix of fast mirrored along with high capacity parity storage. The big thing though is if you've ever had to create a fixed VHD or VHDX, you would know that was a really slow process, regardless of how fast the underlying infrastructure was that you had. You could have the fastest SSD on the planet, but you were trying to create a VHD on a file system, that being NTFS, that's been around for 20 years, and it was never designed to have the size files, to have the size partitions that we're creating that, because it was writing zeros to files all the time. So zeroing I/O has been eliminated in Server 2016. It's gone. It's not deferred, it's not delayed, it's gone, meaning that we use metadata instead of writing zeros. This means that we do instant VHD creation, and we do very fast, efficient checkpoint merge. So whenever you have to merge a virtual machine, we drastically reduce the I/O for cleaning up checkpoints. So this is dramatically quicker in Windows Server 2016, and I'm going to show you that in a second so you can get an idea of what that looks like. So the best way to really have a look at that is to really show you what RFS performance actually looks like. So let's have a look at RFS performance on a very fast storage system. Okay, so let's have a look at some of the RFS improvements that we have in Server 2016. So in this particular scenario, I've got 2 drives, and I formatted one with NTFS and one with RFS. They're both sitting on identical hardware, which is really fast SSD storage, just super fast storage. Now, NTFS, as I said, has been around for 20 years, and it can't deal with some of the sizes that we're actually throwing at it. So let's go ahead and have a look at this demo. So first off, what I'm going to do is I'm going to go and create a new fixed disk. And I'm going to create a new hard drive, and VHDX, create a fixed size. And we're going to put it on our NTFS partition. That's just a link to that. And we're going to say it's 200 gigabytes, and we'll hit next, click finish. Now, in this case, to create this virtual hard drive, you see that we're not actually benefiting much from the speed of the hardware that we have. This could take a while to do, so I'm going to cancel that out because it's just going to take so long to actually do it. Now let's do the exact same thing on REFS, and we're going to do a fixed disk, but this time we're going to choose our REFS partition, same size, 200 gigabytes, hit next, click finish, and before you know it, you haven't even clicked finish and it's done. That is how fast we're able to create that. Now we're going to move up to a couple of checkpoints. One is NTFS, and I've got a bunch of workload churn here, and it's done about 64 gigabytes of writes, and I'm going to delete that checkpoint. And that's going to go through, because you've deleted a checkpoint, that's going to have to do a merge. And that REFS scenario is going to take about anywhere from 20 to 25 seconds to do that merge in progress. Remember, I said that this did 64 gigabytes of writes, and it's going to take about 30 seconds. Bang, it's done. Okay. Now, if we go and do that with an NTFS, and do the same thing, it'll get up to about 4 or 5%, and then it'll just sit there for a while. We're not very good at progress bars, but it's going to take a long time for that to actually do that. So REFS, if you haven't done it already, if you're testing out Windows Server 2016, switch your VMs over to that. You'll get amazingly good performance out of that. Okay, so I wanted to thank you all for taking the time to come to this session on our software-defined storage. And really, in review, there's some objectives and takeaways. Is that Microsoft is a cloud company. We're not a storage company, but we give you a lot of flexible choices across the breadth of storage that's available today. We give you not just the bits, but also the choice of integrated solutions. And our goal is really to help you slash your storage costs by using software-defined storage. We are making huge investments in this, and we've added new features into Windows Server 2016 around storage spaces direct. And you can use all these different scenarios that you see on the screen here, whether it's SAN alternatives using storage spaces, block storage, file-based storage, or using the cloud fabric. We believe that there's the industry is moving quite a way towards software-defined storage, and Microsoft is heavily investing in this area. If you are playing around with Windows Server 2016, and particularly around storage, there's a number of different guides that have been released. So make sure you check those out. If you go to the Windows Server user voice in regards to storage, that's where the product team is listening to your feedback. We have some deployment guides that are available, particularly around storage quas, storage replica, rolling cluster upgrades, and storage spaces direct. And as I said, if you go to Windows Server ws2016.codeplex.com, there's a base lab of VMs that you can build and allow you to play with a whole bunch of things in regards to Windows Server 2016. So with that, I'm going to thank you all for attending today's webinar. We will be on answering questions during the webinar today, as we always are. So if there's any final questions, we'll take those in the chat window. And we hope to see you again on an upcoming webinar. Thanks very much for attending.